Welcome back to our Neo Protocol Smart Contract series. If you wonder how gaming giants like Axie Infinity track millions of player stats, or how Uniswap manages thousands of trading pairs, today we'll learn about arrays, a simple way to store multiple values of the same time in fixed size collection. Let's see how they work with practical examples in our smart contract functions. Let's start with our first smart contract function that tracks player scores in a game. So let's create a public function, track player scores, will return string, and let's create our own array. Starting scores will be user2, we'll have 5, and here so array use type and size syntax, where the type specifies what kind of data you are storing and size must be known where you write the code. You cannot change it later. This makes arrays memory efficient and fast to access. Here is every value is 100. However, we can change it. We can write it in another form. Let's write players also user2, also 5, and let's write different values, maybe 200, 180, let's be like this. Need to mention that arrays start from 0. So if you want to find the third player or third item, you need to write 2. If the second, first, if the first, you need to write to 0. Also, you can update the scores. So let's update the third score. Just write player scores 2 equals, let's be 250. So now let's explore common array operations. For this, we'll write the second function that will manage our voting results. Let's create public function managing voting results. Also, we'll return string. Let's create a mutable array with proposal votes. Let's build also u32, also 5 numbers. Let it be, I don't know, 32, 15, 96, 23, and 87. So our first array operation, it will be get the length of the array. For this, let's write total propose and total propose equal propose vote dot len and brackets, circle brackets. It will return 5 as here we have 5 values and we set of our arrays 5 numbers. That will we have 5. Another great operation is to find the highest vote, the maximum amount in our array. For this, let's write, I don't know, winning votes, and we'll take from our proposal votes. We'll iterate with it. After that, we will find maximum amount, and we need to copy it. Instead of write a big loop to find the maximum value, you can just write this short form with one line. And also, I almost forgot, because maximum is return then option, not a number. So to convert it to numbers, we need to write in the end unwrap. Right now we'll have no arrows. Another operation is checks if value contains in this array. So let's write this operation. Let past proposal votes contains, and contains, let's be, I don't know, 50. Contains provides bool check, so it returns or true or false. Now I will show you how to swap two values. For this, let's write proposal votes swap. Here we write our indexes. I will remember one more time that our indexes started from 0. So if you want to swap first element, you need to write 0. And I will swap with our third element. And the final one is we can sort our an array from the lowest to the highest. For this, we need to write proposal votes sort This operation shows modern Rust techniques for array manipulation. It makes your smart contract code cleaner and more readable. Before we will interact with our smart contract, I found that I did one mistake. I forgot here double dot. Also forgot to make immutable our player scores, as here I changed the value. So don't forget to put mutable because we change our arrays. And also here should be the ampersand. So let's right now interact with our smart contract. Contract, call function, read only. Let's track player scores. We have no values to put inside. Testnet, yep. As you can see, player third score is 180. Yep, it's true. Also, right now the new score is 250. Yeah, we can see it here. And started scores, it's 100, 100, 100, and 100. Let's call another function. Oops, back. Let's no else testnet now. Here you can see total the length is 5, maximum void is 96. Yeah, it's the highest here. Contains 50, it's false, it's no 50 here. After swap, we swap the first and the third. As you can see, 42 and 96 is swapped, and it's right now sorted from the lowest to the highest, 15, 23, and etc. That's arrays in Neo Protocol smart contracts. Remember, arrays have fixed size known as compile time. Use square brackets notation for access and support common operation like searching, sorting, and iteration. Drop a like if this tutorial helped you understand arrays better, and tell me in the comments which operation was your favorite. Let's keep building this developer community together. Subscribe for more Neo tutorials and drop your questions in the comments. See you next time.